Alright, so now that we know that normal distributions are described by their mean and standard deviation, time to talk about z-scores. A z-score indicates how many standard deviations away from the mean a value lies. It's a nice and easy definition, which in this case leads to a nice and easy formula. So to calculate a z-score for a value, simply subtract the mean and divide by the standard deviation, or you can also use the Excel standardize function. So if we look at the normal distribution of Olympic basketball player heights from the last lecture, this right here means that our variable x, which represents height in centimeters, follows a normal distribution with a mean of 195.2 and a standard deviation of 10.26. And say we want to know how many standard deviations taller than the average basketball player Michael Jordan is. Well, he's 198 centimeters tall, so if we plug that into our function, we get a z-score of 0.27. And we can show it like this as well in what's known as the standard normal distribution, or z-distribution, which has a mean of 0 and a standard deviation of 1. And just to show another example, let's take a look at Shaq, who, as it turns out, is a little over 2 standard deviations taller than the average basketball player, which is quite a bit. As you can see from the distribution here, not a lot of basketball players are that tall. Now let's jump to Excel and calculate some z-scores ourselves. I'm going to go to the z-scores link, and what we want to do is select a student from this drop down here and figure out how many standard deviations away from the average is this particular student's MBA grade. Assuming, of course, that MBA grades follow a normal distribution with a mean of 80.17 and a standard deviation of 6.17, which is what we defined in the last lecture. So let's bring over the grade for this student. We can do this a bunch of different ways. I'm going to use the VLOOKUP function. So I want to look for this value in this range right here. Well, in the left column actually of this range right here. And I want to return the MBA grade, which is on the second column here. So column index number is going to be 2. I want an exact match. Press enter. And we can see that student 8 has a grade of 88.7. And if I change this, say to 19, then we get 96.1. So we got our grade working correctly. Now let's calculate our z-score, and I copied over the formula from our PowerPoint presentation right here. So we want x, which is our grade, minus mu, which is our mean, and let me wrap this in parentheses, and then divide that by the standard deviation, which is this right here. Press enter, and we get a z-score of 2.58, which is quite high, but it does make sense given that this is one of the highest grades in the entire class, and it's very close to 100, which is the maximum grade. Now let's check another student. Got 25. He got a grade of 79.1, which is very close to the mean. In fact, only 0.17 standard deviations smaller than the mean. Now let me replace this formula with the standardize function instead, just to show that we get the same result. It's going to ask for an x value, which is a grade, a mean, which is this one right here, and a standard deviation, which is this right here. Close that, and we get, again, negative 0.17. Let's look at another one. And we get 0.73 here with a grade of 84.7. So those are z-scores for you, which in essence help determine how extreme values are in the context of their distribution, depending, of course, on how far away they are from the mean. And in the next lecture, we're going to cover the empirical rule, which is going to give us a better framework for interpreting these numbers.